I'm going to talk about what plans or maybe hopes we have for the future when it comes to building leakage. Unfortunately, there is no time to go into any depth when it comes to ventilation system, duct air leakage in this presentation. So I'll talk only about the facades. Right. I have some 4 main points that I cover the topic I want to talk about now. We can group them into, you call them push actions and pull actions. When it comes to what we see that the building trade in Norway, well, from experience, in improving its quality when we have actions in terms of improved regulations. And self-policing is not something really we can, from experience, rely on very much. So the most important actions are, regulations and other actions related to people to improve quality of their buildings in terms of like contractual arrangements, legal practices. And then lastly, I'm going to talk about focus on improving the competence of the building trade that we the last 2 presentations have talked about. But first, just going to have a look at the situation we have today, and there is a large amount of out there already published and established practices for building in Norway, and it's the same in the other Scandinavian countries. In Norway have a online subscription service for building details, and it numbers quite a few hundred details, but of which about less than 70 actually mention the topic of airtightness somehow. And here in this picture you see an examples of details that you can find in these guides. These details they cover a number of topics in the same guide. They maybe cover thermal, moisture barrier, and wind barrier, and all kind of a holistic way in the same guide. And 12 of these guys mention 12 of them mention the topic of the N15 number, so it's actually quite a large number. Now we're going to take a look at recent projects we have. Just an example of what Torbjørn has been talking about, and there's an example of the situation in Norway. This is a new housing estate which is in the west coast of Norway. 73 apartments, and quite a late stage in the planning. They decided to have quite an ambitious energy level with a leakage number of 1, quite less than the building regulations. And the builders had no prior experience with airtightness measurements or details related to how to minimize it. And what they achieved is this is a graph of the airtightness measurements for each of the individual departments, and we have the y-axis at the right at the top of the y-axis is the building regulations from 1997. The present building regulation has 2.5. So the requirement they set for this project was 1, which is quite a bit less. And as you can see, they achieved it for all the buildings, virtually all of the buildings in the end. We have the dark blue bars are early height measurements using rather simple equipment. And the last bars, the light blue bars, they are measured as built. As Tom said, sometimes the measured as built, the final measurement can be higher because sometimes you puncture the wind barrier. Anyway, from this were quite clear, and they were that even buildings that don't have any competence, prior competence about this topic, they can actually achieve acceptably airtight buildings, and they can do it repeatedly in a building process. And this involves using these early wind-tight methods. We see that testing is really important. Each individual dwelling has been tested in this case. If we tested only 10% of the dwellings, I guess that quite a large number of buildings would not really have been. Well, we cannot guarantee that all of the dwellings would have been less than 1 and 50 less than 1. So, using very simple equipment, leakage testing equipment, to test all the dwellings is a great benefit. See that if they had thought at an early stage about planning to achieve good airtightness, they could actually reduce the costs even further, so they wouldn't have to go in and so the problems they found with leakage points during the early wind-tight stage tests. There is a certain amount of competition between different in the country, and we have some cases where you can achieve less than 0.1 8 inches per hour, which is exceptionally good, we think. But and to do this, you have to have good details, testing, and good workmanship. We have flagged this as a possibility. It can be some maybe find it be tempted to assume that they can achieve such high levels of airtightness when the energy performance calculations during a design stage of a building, and this is a very risky. Because to achieve such high levels of airtightness is rather difficult. 1 is not so difficult, less than 1, but 1 that's exceptionally difficult. So it's important not to be tempted to assume such high levels. Go to actions. When it comes to actions, I would say compliance and having some form of code of practice for contracts maybe are the 2 most important issues I think we have to look at in the future. Now, as to what we have now, well, soon we will have third-party leakage tests, and it's still not really fully decided what exactly this is going to be done. There are a number of questions related to that, so we have to look at. We can be tempting to use the simplified test methods, but something that we would not necessarily recommend for third-party tests. And would it be possible to maybe reduce costs by testing, say, 10% of the dwellings in a building in a housing estate? I think that would be that's very cost-effective, and I hope that's something that we'll be seeing. And we could see something similar to the approach that used in Sweden for testing of duct airtightness. you start off with the contractor advised to include the cost of testing in their contract. They don't have to test theirs. They can subcontract to a professional who tests, and they first have to test 10% of the duct area. And if that fails, they have to repair that, and then they have to test an additional 10% of the duct area. And if that fails, then they have to test the whole dome and the whole building. This approach is something that France has picked up on, and we might be seeing that in, let's say, French housing estates. You start with, say, 10% of the buildings, test that, and say, have to test more of the buildings. I think that would be a good thing to try in Norway as well. When it comes to the similar approach has been suggested or used in the UK in the most recent amendment to the part regulations, where contractors can assume a low leak N15 number in their energy calculations if they have conducted spot 10 housing estate that show that they have, a certain level. So I think that'd be possible to do something similar in Norway. Let's say contractors with a good track record can be allowed to use lower N15 numbers because they can document it from earlier tests. Another issue that has seen, and that is in some cases it's impossible to fully remove leakage of building if they haven't done the early wind tide measurements, and they find at a very late stage that it's way too leaky, and they try and solve the problem by using foam, etc. But it's very difficult actually to achieve significantly reduce leakages, and if that's the case, then the contractor will have to pay economic compensation to the building owner. We lead guidelines for this, something that we're planning to work on. Guidelines related to, let's say, how many years of energy consumption should we pay for? Should we take into account that the building would normally, the airtightness normally changes with an age of a building. So factor all these parameters in and calculate a realistic form of compensation. We hope we could work on some kind of contractual norm in the near future. When it comes to energy performance calculations and energy labeling, has a very liberal energy labeling scheme where building owners can actually do the self-certification. Well, if they're not competent enough, they subcontract it to a so-called professional who can do the energy performance calculation. But homeowners can actually do it themselves. There's very, very simple software on the energy labeling website that anyone should be able to use. So when it comes to leakage testing, there's no requirement really to this labeling scheme to perform leakage tests, apart from if you want to achieve energy level A, which is equivalent to the passive house standard. We could look at that in the future if there's maybe gives more incentives for people to conduct leakage tests. And we also see when it comes to the National Energy Performance Calculation Standard, which is NS 3031, there is a table with default values for air leakage, which you see at the bottom of this slide. And for a dwelling after 2007, you're allowed to assume a value of, say, 2.5, which is maybe a bit optimistic, because if a builder has done any leakage test and are not aware of this issue, experience tells us that you're more likely going to achieve a value of about 4. So it one thing would one good action would be actually to increase the standard values in the energy calculation standards, and maybe enforce some form of documentation if people want to use better levels. They may have a contractor who has a good track record, or they have to do leakage tests. Now, there have been a number of issues related to air leakage testing that we need to look at, and we hope to publish some kind of a guidebook in Norway covering these issues related to one thing is that the most important thing, the thing that takes the most time, is preparations, and it's important to have a very good simple guide that anyone can understand, maybe illustrated, showing the important steps in preparation, so they check so they actually manage to do it properly. There are other things that such a guide could cover, such as where should you locate measurement equipment. Say maybe have a door which would be particularly leaky, and then you shouldn't really put the blower door there, because then you wouldn't be measuring the door leakage. And then there's a question of the interpretation of measurements. Now there is ongoing work in ISO related to updating the air measurement standards, and we hope, well, when that's conducted, maybe to, let's say, start working on some kind of national guidebook. Another question is how we test large buildings. When you have apartment buildings, the practice now is that you don't have to have counter pressure in neighboring apartments. You just measure the leakage by putting a door in the entrance door to the apartment, and then or maybe the balcony. No, I think entrance door to the apartment, and then you measure. Actually on the balcony door, and then the leakage that you measure, you don't know if the leakage is actually to the facade or to the neighboring apartments. Anyway, that's why we interpret the building regulations. The N50 number is tested in that way. When it comes to testing, sometimes it's not possible to test leakage for very large buildings, and we want to follow the experiences that we've seen from other countries in testing or leakage in very large buildings with air handling units. And we've been kind of mixed experience. So maybe we would like to include the best experiences in this guidebook and how to do it really properly. Also is related to thermography and practice of using anemometers to check for draft risk points, which I'll just mention now. This issue of these simplified testing fans that you can buy for cheaply, and or things that are intended for carpenters to use, so that tool mentioned, we found have been an absolutely excellent tool for builders to use during the building process. And we will see continued use of these units, and we hope that other countries can learn from our experience and do the same thing. When we start doing third-party leakage tests in the near future, they will be, of course, using these simplified equipment, because they're not really accurate enough for third-party documentation. So third-party tests will be still using blower doors. But there's still a question of can a builder certify themselves, do self-documentation when it comes to energy performance or energy labeling, and using these very simple tools. There's still some question we have to solve when it comes to that. How acceptable are these simplified tools for proper documentation? We really don't know. Likely that they will have a slightly lower status than proper blower doors, but we're not sure what kind of level of status they will have. Last thing related to measurement is this contentious issue of using anemometers to locate drops. Let's say you have a building with 50 pascal over or under pressure, and then you locate small with an anemometer by placing the anemometer right up to a crack in the facade. One kind of rule of thumb is that if you measure 1 meter per second, then when is in a normal operation, where then you maybe have, say, 4 pascal pressure difference over the facade, then you'd have a velocity of a 0.1 4.2 meters per second in the occupied zone, and near point, something that causes draft risk. So this is a very it's a very uncertain way of documenting that the building has a draft risk problem. So find out if this can be accepted as good enough documentation. This kind of test method is acceptable as good enough documentation at an early stage during the, let's say, as handover documentation that the contractor has to reduce the leakage problem. We personally think that this method is not good enough. Maybe we have to find a higher threshold level to make sure it's more certain. Maybe more than 1 meter per second, maybe 2 meters per second. We'll see. When it comes to certification of air leakage testers, there is no certification in Norway. There is a certification scheme for thermographers, and that seems to be functioning well. There is presently no scheme for leak testing. The companies that conduct leakage testing, they can be members, and there is an association, voluntary member of an association, because Norwegian, Norsk Klimaskjerm, Norwegian facade, and a very good forum for leak testers to share experiences and maybe improve their competence. But such certification schemes or association memberships, they do not guarantee quality. We see that. So these are not really good enough. We have to measure this as well. When it comes to using air handling units for measuring, testing buildings, as Tom mentioned, it's possible to do this in a small scale, also for apartment buildings, but of course use it for our commercial buildings. And we hope that we can conduct more experimental work in the future to find out, let's say, better guidance for this that we can include in this, let's say, measurement guideline that we'd like to publish. The issue of improving competence in the building trade, we have, as Tomer said, this issue of early wind tight testing seems to be successful, and it's an ongoing process happening this day. As Tomer said, it's called training by doing. We have things we'd like to have in the pipeline, or that are in the pipeline. We've been working on better solutions for critical details for passive house buildings. This is a documentation. This is a publication that should be maybe come out this year. Also, similar thing for concrete buildings related to passive house constructions. There are a number of critical details that we know from experience are a big problem in buildings. For example, the popular thing that's becoming increasingly popular, that's using prefabricated bathroom modules. And these are notorious when it comes to leakage. Something we know is a problem and has to be solved somehow. We like to improve awareness on use of good details and planning at an early stage of the building, planning for achieving good airtightness. And one ability is to have like a pocket-sized collection of robust details, also the real details of passive house buildings. And we would also maybe look at the issue of design tools that business can use to very simply calculate, estimate beforehand what kind of level of airtightness the building should have.
Excuse me, Peter. Yeah. Excuse me, we are running a little bit out of time. So,
okay.
Did you?
This is my last slide.
Oh, okay. Thank you very much. So we can take questions after.
The criteria for level of airtightness products is also something that we are going to start to look at now. Issue to say how long do they last and what kind of requirements we need for them. Sleeves that you install around patients and facades, such as around ductwork, etc. So we need to have criteria for all these things. That was my last slide. Thank you for your attention.